Welcome to Day 5 Statistics for Data Science. We are in the course of 100 Days of Data Science. You're watching Data Science Refresher by Benchstudy Education. This is a continuation from the previous lecture. We are studying what is statistics. We studied data types, measures of central tendencies, measures of variability, and now we would be looking more into regressions again. Continuous probability distribution. So before starting it, I would remind you that the homework for these two lectures is to remember all the definitions properly by heart, including the graphs and also the formulas that are given in these slides. The slides you can download easily and the links are for the download for all the lectures, and also the PDFs for and PPTs for these particular lectures is given in the description link below. So coming to continuous probability distribution. Uniform distribution. It is also called the rectangular distribution. It is a probability distribution where all the outcomes are equally likely. Normal Gaussian distribution. The curve of the distribution is bell-shaped and symmetrical and is related to the central limit theorem, that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger. So these are the three graphs we discussed previously. We also discussed more about exponential distribution, chi-square distribution, Bernoulli distributions. The graphs for these we have also covered in detail. Like we use lambda for exponential distribution and we use k for chi-square distribution. Also in the previous lecture we discussed more about the mean median mode and a few more other details related to statistics. So in the continuous probability distribution we also have the binomial distribution and the Poisson distribution. The binomial is the distribution of the number of the successes in a sequence of n independent experiments, and each with only two possible outcomes, namely one is success with a probability p and zero failure with probability 1 minus p. In Poisson distribution, the adjustment that expresses the probability of a given number of events k occurring in a fixed interval of time, if these events occur with a known constant average rate lambda and independently of the time. So these are the three formulas. Formulas are important. Definitions you have to learn by heart. So a formula is for binomial distribution. It is if x is 0 or 1, otherwise we'll get p in case x is 1, and we'll get 1 minus p in case x is 0. For binomial distribution, function x is equal to fx, that is integration of nx p raised to power x multiplied by 1 minus p raised to power n minus x if x is 0, 1 till n, and it will be 0 if otherwise. In Poisson distribution, the formula is function of k and lambda, which is equal to PR, which is multiplied by capital X equals to k, which is further equal to lambda raised to power k multiplied by e raised to power minus lambda divided by k followed on. So these are the formulas that you should remember. We would be seeing their applications also in this particular series. Right now we don't want to overburden you and with information bombarding, so we don't want to do that. So we want to take it easy. And so coming to the null and alternative hypothesis. So null hypothesis is a general statement that there is no relationship between two measured phenomena or no association among groups. Alternative hypothesis be the contrary to the null hypothesis. In statistical hypothesis testing, a type 1 error is the rejection of a true hypothesis, while the type 2 error is the non-rejection of a false null hypothesis. So as you can see, we have a matrix. We have the conclusion matrix where we have if we are accepting the null and H0 is true, we'll get a correct, and if we reject the null and H0 is true, we'll get a false positive. And then similarly we can get false negative, which is a type 2 error, or we can get the correct answer. So these are type 1, type 2 errors which we can get. Further, you should also be knowing very important concept, that is ANOVA, analysis of variance. This is one of the most important parts if you are studying from some exam point of views. ANOVA is the way to find out if experimental results are significant. One way ANOVA compares two means from two independent groups using only one independent variable. Two-way ANOVA is the extension of one-way ANOVA using two independent variables to calculate the main effect and interaction effect. So you get the ANOVA table on the left hand side, where you have in source, it can be a treatment, it can be error, and we have the total. And we in the columns we have the sum of squares, degrees of freedom, mean squares, and f functions. So here these all these particular sum of squares and degrees of freedom we would be going in depth. These are very important concepts, and in coming lectures we would be going in depth also. So you should have some idea. You can read more about it maybe from the internet, and start preparing for yourself for stronger concepts later on. Coming to regression. So in linear regression, first we have assumptions of linear regression, that it is linear relationship, it is multivariate normality, it is no or little multicollinearity, there is no or little autocorrelation. Linear regression is a linear approach to modeling the relationship between dependent variable and one independent variable. An independent variable is a variable that is controlled in a specific experiment to test the effects on the dependent variable. A dependent variable is a variable being measured in a scientific experiment. The formula is yi equals to beta 0 plus beta 1 xi plus epsilon I. So this is the error. We can also write it as EI. So this is the linear regression formula with the graph. Multilinear regression. Multilinear regression is a linear approach to modeling the relationship between a dependent variable and two or more independent variables. The formula is y equals to beta 0 plus beta 1 multiplied by x1 plus beta 2 x2 plus beta 3 x3, and so on till error term E or epsilon. This is the formula for multilinear regression. So you should remember these by heart. In the upcoming lectures, we will cover the following topics in depth. Sample mean, sample median, and sample mode. We would be covering sample variance and sample standard deviation. We would be covering sample quantiles besides the median, example quartiles and percentiles. We would also be going to discuss the test statistics like the t-test, chi-square test, f-test, etc. We would be discussing more about the order stats, that is including the sample maximum and minimum, sample moments and functions thereof, including kurtosis and skewness, and various functionalities of the empirical distribution functions we would be discussing. So I hope you liked today's lecture. So the gist of the lecture is, you at this moment try to understand what has been delivered in this lecture, and by going back to the lecture slides, you can pause them or you can download the PDF or the PPTs. You can learn on all the definitions because these are the basic building blocks. You can search over the internet. We would also be providing you some resources from where you can learn more about these resources. And then in the upcoming lectures, we would be going in depth with sort of examples, with sort of visualizations, graphic visualizations, and also we would be discussing these topics in depth, in detail, without leaving any part, so that you are also, if you are preparing for interviews or exam point of view, you are well prepared, so that any question you can answer. So if somebody is looking for authentic government jobs, exams and result notifications, you can log on to sarkariresultanjobs.com. The link is in description. That is, thank you so much for your time. This is day 5 of 100 days of data science. You are watching the Data Science Refresher by Venture Story Education. Thank you. Have a nice day.